Hi there! This video series is to display my problem-solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I'm showing my approach to solving the 36th Project Euler problem from start to finish, vocalizing my thought process throughout. As always, I will link to Project Euler and my repository in the description. Let's dive in. Problem 36 is double base palindromes. The decimal number 585 equals this in binary is palindromic in both bases. Find the sum of all numbers less than 1 million which are palindromic in base 10 and base 2. Please note that the palindromic number in either base may not include leading zeros. Easy enough, I think. So, go ahead and start our problem file. Okay, so the reason I say that this is probably relatively easy is because I think that Python has functions for determining palindromes. So let's start there. So let's see, limit of 1, 1, 2, 3, 1, 2, 3, so 1 million. And trying to go back to our problem page. Okay. Python is palindrome. Okay, so here's one simple way to do it, which is to just change it to a string and then reverse it. So I would say we probably want to do something like this first thing, but we want it to be converted back to a number so that we can do the equals on the number. So let's go ahead and make this little as palindrome method, except do Python. And then what we can do here is just wrap both of these inside of an int call to convert them to integers, and we're done. So I'm going to go ahead and break this stat back down to 100. And just do for in in range 1 to limit if is palindrome. I do not need these parentheses. This is not Java. And then we print out. Okay, so this should give us a few. Oh. Now, obviously, this is only about half of our requirements. Let's see, so let's make sure we have this correct. Okay, so we are successfully finding for base 10. What we need to do is be able to convert to base 2. So Python convert to binary. Apparently there is a binary function, and it is built in. So if we just do is palindrome string version of the binary version of n, okay. Invalid literal for int with base 10 ob1. Let's try without this string part, but I'm guessing that that is also not going to work. Yeah. Okay. Just casting it 3 times here. Okay. Well, okay, that makes sense, obviously. So 0b1. Let's go ahead and print n. So we know, I think this is just 2. S is equal to S. Okay, so it appears to not work. Okay, so we need to remove this prefix, I think. Oops. Okay. Kind of want to see... Okay, so this isn't too many, I think. we're just going to go through and we're going to see, okay, if any of these are... Let's look at the binary representations of these numbers that are getting pulled in as palindromes. So this is obviously going to be 1, 8, no. So wait, going back to the beginning, 1, not 2, not 3, not 4, 5 is 1, so 1 and 5, 7, 1, 5, 7, 33, 1, 5, 7, so 3 is still... 3 is selected. Let's double check 3. Yep, that's correct. Okay, so we no longer want to print all of this nonsense, and we want to get rid of this noise. Going again. Change this limit back to 1 million. Takes a little bit longer, but there we go. Obviously, it completed in about a second, maybe half a second. And this should be the correct answer. And it is. So, pretty simple. We created our own little isPalindrome method, where we basically took in whatever the number was as a string, and then took the integer version of the string and used the, I forget exactly what this is called in Python, but this is a really simple notation to reverse the array, and it works on strings as well, because strings are technically sort of arrays of characters, but convert both of those back to integers so that 1, 0 doesn't get seen as equal to, or like, yeah, a leading 0 is always ignored. We might not even need to do the int cast. Let's go ahead and experiment without that part, actually. Just for curiosity's sake. Okay, so that actually does get the same number, because the only way we can get a leading 0 is if there's an ending 0, and if there's an ending 0, then it's not going to match. So, I think this is all good. We set up a limit, we set up an array, we used the Python method to convert to binary, converted that to a string, and removed this little 0b prefix so that we can compare it easily. This could be done with just a sum here. So, like, we could do... I'm just going to comment out the relevant lines. We could have a sum equals 0, sum plus equals n, and then just print sum, and that would also give us the correct answer. The only reason I printed out the array, and actually that works maybe even a tiny bit faster, but the only reason I went with the array is so that I could print the array out and have that visual sort of confirmation, is my code working? But either way works very, very well. We're relying on some built-in Python methods. This is the only, well, really, like, there's not very much fresh logic to this solution. It's just for loop all the way over all these numbers, convert each number to a string and check whether that string is a palindrome, convert each number to binary, convert that to a string, check what that's a palindrome. And that's it, really. So, I'm going to call it there for today, and I'll catch you in the next one.